All right, so again, this was one way to do this problem. You could think of this as division and then multiply by the reciprocal. That was the first way. Let's take a look at the way we're going to do it now, though. If I had 2/3, again, over 5/2. Now, I want to find an LCD for all the fractions. First of all, where are my denominators in this problem? What numbers?
5.
Good. The 3 in the top and the 2 in the bottom. Those are my denominators. The 2 and the 5 are really numerators, correct?
Mm-hmm.
All right. So out of 3 and 2, what would your LCD be?
6.
6. Okay. Again, 6, because remember, if you're thinking of GCF would be 1. The LCD would be 6, because here we're missing a 2, and here we're missing a 3. Agreed? So if we put a 3 down there, we got to put a 3 up top. If we put a 2 down there, we got to put a 2 up top. So we're multiplying by the fraction 1 over 1, really. Now, what do I end up with? Here I get a 6. This becomes 4 over 6 over 15 over 6. Well, what happens to the 6's now, guys? They cancel. What are you left with?
4 over 3.
Same exact answer you got there. So again, the method I'm going to show you today is a little bit different. And a lot of students don't learn it this way. They learn it the other way that I showed you before. But this method that we did in the start takes a lot more time and a lot more writing and work to do it this way. This way over here is a lot more simple. A lot simpler. Okay? So again, we're going to do it this way, but with variables today. It's the only thing that's going to make it more difficult. So we understand we get the same answer here? Are we clear on that? Both 4 over 15. Why can we cancel these? Because they're denominators of both. Remember, when the denominator of both are the same, you can cancel them. Need another one? You want me to show you that one, guys? Does that make sense? Does anybody know seriously why I'm canceling those 6's? Because I think of this again as 4 over 6 times 6 over 15. And then what happens to the 6's? They cancel. So you're still left with 4 over 15. So we can take this and we can extrapolate it. We can say, from this one here, we see that this always cancels, so we can do it in all cases without showing the work. Next one. Again, please find an LCD for every denominator. So think about it. Out of the numbers 3, 5, 6, and 10. Out of the numbers 3, 5, 6, and 10. We need an LCD for all of those. Out of the numbers 3, 5, 6, and 10. Look at all your denominators. 3, 5, 6, and 10. What do they all go into? What is it? 30. Very good. You settled 30. Notice, 3 and 5 have, 15 or 30 of the first two. For numbers like 3 and 6, it could be like 18. Okay? But 3 and 6 also both go into 30 there. For 5 and 6 is 30. For 3 and 10 is 30. The number you're looking for here is 30. Okay? It's a numerator, guys. Again, remember, we're looking at all the denominators only. All of the denominators only. So out of these 4, it's 30, the LCD. So start by listing that if you need to. Then, please listen, come on. Then, once you realize what's missing in each spot, you need to multiply by that corresponding value. So I'm going to ask people one at a time. Isela, tell me for this one, the x over 6, what's missing? What do I have to put there to make it a 30? Very good. Lauren, for the x over 3. Very good. Jason, over here. For x over 5, what do I have to multiply to get a 30 down here, really? Very good. Okay, Raul, over here. This last one. For 7 over 10, if I want to get a 30, what do I need down here? Very good. Okay, so notice we put all those 4 things there. Be careful as you do this, because there's a lot of work on the page. There's a lot of room for little errors along the way. So in the next line, make this again. You're going to notice you're going to get a 5x right here. You're going to have a minus sign, and then you're going to get a 10x right here. And notice, this is over a denominator. But aren't all the denominators 30s at this point?
Yeah.
So what did I say you can do? Just cross off all your denominators now, because they've all become 30. And just write what remains. And this is going to become 6x minus 21. Everybody see that? Again, take a look at your denominator, see what remains. I'll box it in red, what remains. That's what remains up top. That is what remains down below. And they're both subtraction problems, so we have minus in between for both.
And that one, you can't.
Yes, I mean, you could factor out a 2 up top, or a 5 up top, and a 3 down below, but does that really do anything for you? No, because you don't, I mean, it doesn't really help. Just an alternate way to look at it, though.
Wait, can't you just put 5x over 6x minus 1?
Okay? Say again?
Can't you just put 5x
Shouldn't be
over
5x.
6x minus 1?
Oh, sorry, guys. I apologize. Negative 5x up top. What did I do? Who can tell me? Quick. I didn't put the x with a 10 in my mind. I thought of it this way, guys. Sorry. And in fact, they're not the 5. That's what I did. So, I'm sorry? No, they're both x's. They're both x's, Juliet. We both did the same thing. You forgot, you had the 2 there also, right? Because you thought this is just a 10. But these are both x's. 5x minus 10x is just negative 5x. There's nothing else you can really do here. So, okay? Second problem. Are we clear with that? This was an easy example, though. Keep that in mind, guys. It's a very basic one.
What's the next one be like? X
It's not
squared.
Relax.
What are you doing?
All right. So, what are all of the possible denominators? What's one of the possible denominators? That's up here. What's one of the... 15. Where do you see 15?
X minus 15. X minus 15.
Let's slow down. What is one of the denominators you see on the board?
3. Negative 3.
X plus 5. That's one of them. One of the denominators is x plus 5. What's another one of them?
X minus 3.
And then the last one is also
X plus 5.
x plus 5. So, a common denominator would be what? Just to what, Vicky? Multiply them together. Again, guys, please listen. Come on, there's going to be a lot of misconceptions here. The common denominator is always the product of whatever your denominators are, if you're ever in doubt. So here, you have to say to yourself, up top we're missing an x minus 3. So we'll multiply by x minus 3 over x minus 3. Down below, we have 2 things missing, one different on each side. What's missing on the left side over here, Claudia? X plus 5, very good, over x plus 5. Now again, remember, why do we put 1 over the other? Because it's really a fraction that results to what? 1. Again, x plus 5 over x plus 5 is just 1. So we're not changing the value of the function. We're changing the value of the expression. And John, the last one? What's missing over here? Over. Very good. Okay, now notice all your denominators are like, just cancel them all out again. Just like we did in the beginning. So cancel, cancel, cancel across, and cancel that across. Up top, what are you left with? 3x minus 9 over. Very good. Okay, again. Now down below, we'll see that together we have 3x, and we're going to have a plus 7 down here. And I'd be tempted to factor out a 3 up top to see if it could cancel, but I can see that I can't factor out a 3 down below. So I'm kind of done already. Okay, again, it looks like I pull 3 out of the top, right? And that would help me, great. But there's nothing in the bottom to cancel. So for now, I'm going to leave it. But remember, in case you see it in a different form, you have to know that this is also representable as 3 times quantity x minus 3 over 3x plus 7. That's an alternate solution. Another way to write it. Remember, on that SAT, your answer might be right, but it might not look right. It might not look right. All right. Questions on this? We're going to do one more. So far, questions?
Wait.
1 or 2. I forget if I did 3 or 4.
So, I'm going to finish my maybe like x minus 9 is 2x plus 10 we added to x minus 3 3x minus 9.
Now, John, this is 2x plus x, which gives you 3x. 10 minus 3 gives you 7. Combine like
10
numbers.
minus 3.
Oh.
Okay. Questions? Now, if we had done this the other way, where we got the same, if we had done this the other way, where we multiplied by the reciprocal here, for this kind of a problem, we would need to make the bottom one fraction, make the top one fraction, and then multiply by the reciprocal. It's a lot more work. Okay, a lot more work is involved that way. So this is literally like half the time it takes you. And a lot of people don't know this method for the SAT. This is very good because complex fractions are one of the topics in the SAT. Okay, it'll come up. So I'm just giving you a heads up now. Next one.
Me too. I never liked them.
A lot of people make a common mistake here, and I want to ask you this. I don't want to know what the right way to do it is. Who can tell me what the wrong way to do this would be that you think most people would do?
Adding the X's.
Not adding the X's. Daniel? Not canceling top and bottom yet. I could see that. I could see them just starting by canceling those or something, sure. Even though that's not allowed either. Miguel? Okay, that's one of the ways for sure. Sorry, that's another way of being common state. I was thinking of something different.
Add 4 to the X.
Yes. A lot of people might do this. Oh, you know what? I'm just going to go ahead and throw a plus 1. This is just pretty easy, right? Now, again, we know we can't do that. Then they say cancel, right? You can't just add a number to it. So, one of my denominators is x plus 4. Another one is x. We must have the product of those numbers in our denominators, not the sum. Again, you can't just add a 4 on. So clearly we're missing an x plus 4 here, an x plus 4 here. Notice the parentheses. We're missing an x in both of these. We're missing an x up top as well. Now look at all your denominators. They are all identical. Cancel your denominators. And this results in a simple 5x over x plus 2x plus 8. Now, the cool part that I really find about this is that we spent, 30 seconds to do that problem, not even, right? If you did it the other way, where you found a common denominator for the bottom, and then you multiplied by the reciprocal and did all that work, it's like twice as much work when it comes to time. You're really cutting your time in half. And what I want you to do, especially tonight, is this. When you're doing your homework, do it this way, obviously, because I want you to do it this way. But also look at the links that I'm going to put up online, because I'm going to put up the other method, just so you can see it. I want you to see how much more work it is. Just read through it. So you'll see, as always, you're going to see there's going to be 1 or 2 readings tonight again. You'll see 2 readings under news and then 2 videos tonight. Look at the readings, because one of them is going to show you a way that I really don't want you to do, but I want you to understand where it comes from. So you can still read through it, but I want you to use this method when you do the work. Did I do a 4 today? No, that's it.
That's it.
Yep.
Oh, we done. Let's start on our homework.
That is it.
No.
Here's your homework. Get started, please. You have 8 minutes, guys. 8 minutes. You can get done with almost all the homework here.
The whole book.
If you use today's method, you can get the whole homework done.
Now
8 minutes.
You guys are gonna like it. Book is actually
Okay.
This dude's like,
why you gotta talk to you right now? I know, you guys seem like that everything. You knocked down Disney. What's wrong with you? Mr. Howell, he's never seen a Disney movie before in his life.
Are you
No, he's never seen Hercules. He's never seen Aladdin. He's never seen...
it's okay. One day you kind of wants to.
That's it. How's that possible?
You ever seen Hercules?
I know the concept.
You know,
Oh, he knows the concept. He knows the plot. Well, did you read it on Rotten Tomatoes? Did you read a critics?
People, get started, please. Let's go. This is not free time. It's time to do your work.
Really do it now?
Crazy. We can do 4 or 5, 6 examples, but I'm trying to give you more time here.
Never